right, today we're going to crack the code on something you use every single day, whether you realize it or not. I'm talking about the metric system, and I promise by the end of this, you'll see it's not just a bunch of numbers, it's actually kind of beautiful in its simplicity. So let's dive right in. You know that feeling, right? You're in the middle of a recipe, everything's going great, and then bam, it asks for 250 milliliters of milk. And you're just standing there holding a measuring cup thinking, ugh, can't you just say 1 cup? We've all been there. That little bit of confusion, it's super common, and it usually boils down to some really tiny, easy-to-make mix-ups. So where does the confusion come from? Well, a lot of it starts with prefixes that sound almost exactly the same. I'm looking at you, Deca and Deci. They sound alike. They both have to do with the number 10, but they're polar opposites. Deca means you multiply by 10. Deci means you divide by 10. Get those two mixed up and you've got a big problem. I mean, it's the difference between having 10 whole meters of something and just 1/10 of a meter. That's a huge difference. Look, in the kitchen, a mistake like that might mean your cake turns out, well, a little weird. No big deal. But imagine you're a doctor or an engineer. Suddenly, a tiny mix-up isn't just a funny story. A misplaced decimal point in a medicine dose, or in a blueprint for a bridge, that could be catastrophic. So yeah, getting this right, it really matters. But here's the secret, the thing that's going to make this all click for you. Mastering the metric system isn't about memorizing a million different numbers. No way. It's all about understanding one single, incredibly simple idea. The power of 10. That's it. That's the whole game. And this right here, this is what I'm talking about. The whole system is built around a base unit, like a meter or a gram or a liter. Then you just stick a prefix on it. If you move up the ladder, every step is 10 times bigger. So a decameter is 10 meters, a hectometer is 100, a kilometer is 1,000. See the pattern? And going down, every step is 10 times smaller. No weird fractions, no memorizing how many feet are in a mile, just tens. It's so clean, so logical. Okay, so if it's all just multiples of 10, then converting between units should be super easy, right? And you'd be absolutely correct. It is. You just need one little trick, a kind of secret weapon to have in your back pocket. Ready to see it? It's called the Stairstep Method, and trust me, it's a game changer. It's super visual and easy. All you have to do is find your starting point on the stairs. Then find where you want to go. Count how many steps you took and in which direction, up or down. Then you just move the decimal point that exact number of places in the exact same direction. That's literally it. Let's say you want to convert 5 kilometers to meters. Kilo to the base unit. That's 1, 2, 3 steps down. So you take the decimal in 5.0 and move it 3 places to the right. Boom, 5,000 meters. See? Simple. Okay, great, you're thinking. But how do I remember the order of the stairs in the first place? Fair point. Our brains are just not built to remember random lists of words. We're wired for stories, for connections. That's where a little thing called a mnemonic device comes in. Think of it like mental Velcro. It helps new information stick in your brain by attaching it to something you already know. And for the metric system, there's a classic one you might have heard before. King Henry doesn't usually drink chocolate milk. It's a bit silly, right? But it works. Each word's first letter gives you the prefix. Kilo, hecto, deca, then the base unit, then deci, centi, milli. Just say that sentence a couple of times. Picture poor King Henry avoiding his chocolate milk. I bet you won't forget that order anytime soon. But look, the metric system is so much bigger than just converting things in your kitchen or your workshop. Its real power, its true beauty, is its scale. It's the language that scientists use to talk about, well, everything. From the absolute smallest subatomic particles to the most massive galaxies in the universe. And get this, it's not some dusty old system set in stone. It's alive. It's still growing. I mean, it started way back in 1795 with just 6 basic prefixes. But as we've discovered more about the universe, we've needed new words. So the system has grown right alongside our knowledge. In fact, just recently, in 2022, scientists officially added 4 brand new prefixes to describe things on scales that are just, well, they're hard to even wrap your head around. So why would we possibly need new prefixes? Because we're exploring new frontiers. Think about data. The amount of information we're creating is staggering. We're about to start measuring it in zonabytes. Or think about cosmology. How much does the Earth weigh? Turns out it's about 6 times Rontograms. And on the other end of the scale, in quantum physics, the tiny, tiny mass of a single electron is measured in Rontograms. The system has to evolve because our curiosity never stops. So we've covered the how. how it works, how to use it, but now we're going to get to the really cool part, the what and the why. Have you ever stopped to think, what is a meter really, or what actually defines a kilogram? The answers are going to surprise you because they've changed a lot and they tell an amazing story about our relationship with the universe itself. Let's start with the meter. Originally, its definition was, well, it was kind of romantic, actually. It was defined as exactly 1/10 millionth of the distance from the North Pole all the way down to the equator, a measurement literally pulled from the dimensions of our own planet. It was an Earth-based ruler for an Earth-based people. The story of the kilogram is even wilder. For over 130 years, get this, the official definition of 1 kilogram was the exact mass of a specific lump of metal, a little platinum iridium cylinder locked in a vault in Paris. I'm not kidding. The entire planet's concept of mass was tied to this one physical object. Every other kilogram wheat in the world was just a copy of that one piece of metal. But think about that for a second. What happens if that cylinder gets a little bit of dust on it, or if it loses a few atoms over time? Does the mass of everything in the universe just change? It was a problem, a big one. So in 2019, science made a huge leap forward. We decided to stop defining our measurements by things that can change, like a planet or a lump of metal. Instead, we tied them to something that can never change, the fundamental constants of nature. So what's a meter now? It's defined by the speed of light. That's it. We know the speed of light in a vacuum is absolutely fundamentally constant. It's the universe's ultimate speed limit. By fixing its value, we get a definition of a meter that will be the same here, on Mars, or in a galaxy a billion light years away. It's truly universal. And what about our friend the kilogram? Well, that chunk of metal is officially retired. Today, a kilogram is defined by something called the Planck constant. Now, that sounds complicated, but just think of it as a super fundamental number from the bizarre world of quantum physics. It's a value that's baked into the fabric of reality itself. We didn't invent it, we discovered it. And now it defines mass for everyone, everywhere. It's the same for time, too. What's a second? It's defined by the ticking of a cesium atom. These atoms vibrate at an unbelievably consistent and precise frequency. It's like we've tapped into the universe's own master clock, one that never ever skips a beat. And when you put it all together, you see this beautiful interconnected web. Every single one of our base units, the meter, the kilogram, the second, even the unit for temperature, is now tied directly to these fundamental constants of the universe. It's not a collection of random definitions anymore. It's one single elegant system, built on the laws of physics, designed to measure everything. So let's bring it all home. What's the takeaway here? You basically have a new superpower. You now know that the metric system isn't scary. It's actually super simple, because it's all based on the number 10. You know it's practical, because you have the tools like the Stairstep Method to convert anything with ease. And maybe coolest of all, you know that it's universal, literally. It's a system of measurement that any intelligent civilization anywhere in the cosmos could eventually agree on, because it's based on the laws of physics itself. And that kind of leaves us with one last big thought. The metric system is more than just numbers. It's proof that all of humanity can come together and agree on a single, logical way to understand the world, a language built on the very foundation of the universe. So it makes you wonder, right? If we can all agree on something this fundamental, what other universal languages are we capable of creating together?